Hey guys, and welcome to your lesson on common factoring. So to get us started, I want you to consider this. Simplify using the distributive law. So negative 2x times, in brackets, 3x plus 2. So you're going to take your negative 2x, multiply it into your brackets using your distributive law to simplify this or expand this, and we get negative 6x squared minus 4x. So what I want you to think about for a minute, and you can pause the video to do that and jot down a few points that you think of. What if I wanted you to reverse the distributive law? So in other words, if I gave you this question, negative 6x squared minus 4x, and I wanted you to come up with this piece as your answer, how can you do that? What would you have to do? So take a second, pause the video, jot down any things that you think that you might do to make that happen. All right, guys, so there's a couple things you might have come up with. You might have come up with all the pieces, but a few things I want to point out is when we do distributive law, we're always multiplying. So when we're reversing the distributive law, anytime we're doing reversals in algebra, we always think of the opposite operation. And the opposite of multiplication is division. So when we're doing this backwards distributive law business, we're going to be seeing a lot of division happening. The other part is, how do you come up with this guy out front, and how do you come up with this piece in the middle? And that's what we're going to explore a little further in this lesson. So the process of reversing the distributive law is known as common factoring, which is what we're going to be doing today. So if I gave you an expression like this, 2x to the exponent 5 plus 18x cubed, and I ask you to factor it, I'm asking you to find two expressions, or maybe a number and an expression depending on what we're looking at, but two expressions or possibly even more that multiply and give us this as an answer, reversing the distributive law. So the first thing we have to do is determine the greatest common factor, known as the GCF, greatest common factor. And when we're looking at algebraic expressions, the greatest common factor is a combination of the greatest number that we can factor out and the greatest variable or variables that can be factored out. So we're not just focusing on the number part here. In this particular instance, if we wanted to determine the greatest common factor, we need to find the biggest number that we can divide 12 and 18 by. And some of you guys will probably get it in a flash if you're really quick with your facts. Some of you might have to take a minute and jot out your factors. So if that's you, 1 times 12, 2 times 6, 3 times 4, just like we practiced the day after the test, you had some handouts on this. Factors of 18, 1 times 18, 2 times 9, and 3 times 6. And by doing that, you can easily identify your greatest common factor as 6. The next piece, though, is to look at the variable or possibly variables if there's more than one. Here I have x to the exponent 5, and here I have x to the exponent 3. So they both have x's that can be divided out, but I can only take out as many as my fewest or my smallest exponent. So in this case, I'm able to take out 3 x's or x cubed from each term here. So in order to take it out, we're reversing that distributive law. So remember up here, when we multiplied that term in front of the brackets in, now we're going to grab our greatest common factor and we are going to actually divide it out. So we're doing the opposite. So we have to divide the polynomial by the greatest common factor, and what's left over is my quotient. So for my final answer, it's going to look like my greatest common factor times, and in brackets, you're going to have what's left over, that quotient. So for this question here, start with your greatest common factor. You're going to have a set of brackets, and to get what's left over, we have to divide every term by that GCF. 12 divided by 6 is 2. X to the exponent 5 divided by x to the exponent 3. Going back to our exponent laws, when you divide and they have the same base, we just subtract their exponents. 18 is positive, divided by 6, so we have plus 3. And x cubed divided by x cubed, subtract your exponents, we get 0, and it's gone. Or x to the exponent 0, as we know, is 1. 3 times 1 stays as 3. And that's it. That's your answer. You can always do a quick double check by in your head, multiplying this back in using the distributive law and seeing if you end up with that original question, and you'll know you've got it right. So moving down the page here, the difference between factoring and simplifying. Simplifying is when we use the rules of algebra to remove the brackets. So things like distributive law, FOIL, collecting our like terms, maybe adding or subtracting polynomials that have brackets around them. Factoring is the opposite of doing those things. So it's taking a simplified expression and we end up seeing those brackets. So we write our expression as a product meaning multiply, of two or more factors, and we separate them with brackets. So first example here, simplifying, just like distributive law, multiply it in the brackets, 6x squared minus 12x. If you're given a question like this and you're asked to factor it, you need to determine the greatest common factor. So these two, 6 and 12, are both divisible by 6. And I have an x squared and I have an x to the exponent 1. So x to the exponent 1 is the biggest thing I can take out of both. So my answer, I start with the greatest common factor and divide it out. 6x squared divided by 6x is 1x. Negative 12 divided by 6, so I have to put that minus in there, negative 2. The x divided by the x leaves me with no x's. And that's your answer. All right, guys, so flipping to the next page here, we have another example. So you're asked to factor negative 16x to the exponent 4 minus 24x cubed plus 8x squared. So there's a note over here in the side. Oop, don't want that. Note over here in the sidebar. If the coefficient, the number in front of the first term, is negative, then we want the negative to be factored out with the greatest common factor. So in this case, the first term here has a negative 16 in front, so I know my greatest common factor is going to be negative. We want to always pull that negative out. What is the biggest number now that I can actually divide these by? So don't worry about the negative at this point when you're trying to figure factors. Biggest number that you can divide 16, 24, and 8 by. Now I'll give you a little hint. If you're someone who needs to write out your factors, write out all the factors of the smallest number, because it's not going to be bigger than your smallest number. 16 is divisible by 16, but you definitely won't be able to divide 8 by 16 and end up with an integer number. So in this case, the factors 8, 1 times 8, and 2 times 4. That's it. So start with the biggest one. Are they all divisible by 8? Yes, they are. That's your greatest common factor. If that doesn't work, move down to the 4, try that, and so on and so forth. So negative 8 we're going to pull out, and we can also take out x because there are x's in every single term. In fact, there's at least 2 x's in every single term because that exponent is the smallest one on our x. So to answer this question, you pull out your 8x squared, open your set of brackets, and divide each term. So negative 16 divided by negative 8 is positive 2. X to the exponent 4 divided by x to the exponent 2, you subtract those exponents. Negative 24 divided by negative 8 is 3. Subtract your exponents, we're left with x to the exponent 1. And the last one, remembering of course the negative, so positive 8 divided by negative 8 gives me negative 1. X squared divided by x squared, and they cancel each other out. That's it. That's all you've got to do. So here's 2 below. I want you to try question 1 and 2. You got to pause the video, try them on your own, notice the negative in the second one, and then unpause to check your answer. So pause now, please. All right, here we are back at it. So what you should have noticed for the first one is the greatest common factor is 4x. So you pull that out, divide each term on the inside by 4x, and this is what you should have left over. If you did, for example, only pull out a 2x, let's just say. So you've got your 2x, and now you have 10x cubed minus 6. Then you notice, hey, wait a second, these guys are still even. That means you didn't pull out your greatest common factor. If you notice they're still, not that they're even necessarily, but you notice that there is another common factor that you can pull out. So now I know, oh, I could pull out 2 more. This is divisible by 2, and this is. So you don't have to erase everything and start all over, but what you could do is just notice that you also have to pull out 2. And you could have 5x cubed minus 3, and what happens with these guys is they multiply. So we would get 4x. So if you do notice you didn't fully factor it, you can just do that to continue factoring it and getting that greatest number out front if you did miss it the first time. All right? Over on the other side here, you should have factored out that negative 3. You might have noticed as well that we have 2 x's on the first term, 1 x on the second term, but there aren't any x's on the 15. So for this one, there's no variable to factor out, and that's fine. Just pull out your negative 3. Notice your signs. Negative divided by a negative, give me a positive. When these positives divided out by a negative, they both turned negative. So watch out for your integers and be really careful with that. That's it for common factoring in its simplest form, but now we're going to do a little bit of common factoring by grouping. So if you have an algebraic expression where there are 4 terms in it, like the ones below, you might be able to common factor them in pairs. So for the first one here, I'm going to take the first two and group them and find the greatest common factor. So here the GCF is 4x squared. Then for my second set, my GCF, wrong way, GCF is 5. So if I common factor the first set, I get 4x squared, and what's left over is x plus 5. Then I'm going to grab my second set. Now the greatest common factor is positive, so I'm going to write plus 5 because it's still continuing in the same expression. And I get x plus 5 left over when I divide each term by 5. Now you might notice that each of these groups has this x plus 5 piece, and they're being multiplied together. So what I'm going to do now is divide out that whole expression from my blue term here and my red term here. So for my final answer, I pull out that greatest common factor, and all the leftover stuff, 4x squared plus 5, goes into your second bracket. And now you have this factored. So we'll repeat that over here with this one. So first two terms, no number can be divided out besides 1. So 3 and 5 don't have any other common factors. Pulling out a 1 won't change anything though, so we don't even have to worry about writing it. But I can definitely pull out r squared. If I do that, I'm left with 3 times r to the exponent 1 minus 5. Grab your second grouping, noticing that first one there has that minus in front. So we're going to factor out the minus. 6 and 10, the greatest common factor is 2, and I can't take out any r's because 10 does not have an r on it. So I'm left with positive 3r minus 5 because I'm dividing by the negative 2. And then you'll notice you have these common brackets again, one in the blue section and one in the red section. So I'm going to pull that common factor out, and all the leftover stuff gets put in your second bracket. And there you have it, factoring by grouping. So when you come down to the bottom, there are 2 more for you to try. This is it for your video. So pause up your video, give these 2 a try. It's a good practice of common factoring as well as pulling that third factor out at the very end there, and come back and check your answers when you're done. Alright guys, I hope you gave these ones a good shot here, so come and check your answers and see how you did. You should notice with both of them when you did that grouping and then common factoring that you did end up with the same values in the brackets. And then you factor out that common bracket, and what's left over goes in the second one. Just one final note before you finish up for today. If you were to write the 7m squared plus 6 first and then have the 2m minus 3 second, that's fine because we can multiply in any order. So if you put this one first and this one after, or if that's how the textbook has it written in the solutions, that's fine. Alright guys, that's all for today. Thanks for joining me.